Okay, hey everybody, this is the video on Project 3D, and this is my second attempt at this. My first attempt, I was looking at the slides for maps, and then a map stores so-called tuples, and my inner math guy came out, and I started riffing for way too long on what a tuple is. So here's the Wikipedia page on tuples. And if you'd like to know exactly what a tuple means, I would love to spend minutes talking about it. But really, what I want people to hear when I'm saying tuple is an ordered pair. And so maps store, two tuples, an ordered pair. And the ordered part means that if you say key value, that's not the same as saying value comma key. That the first element in the ordered pair, the first key in this case, goes in one spot, and the second value goes in another spot. And so maps are going to store both a key and a value. Um, and so you give it a tuple, a key and a value to store, but later you can retrieve it with just the key, and then it will give you the value. And then if the key is not in the map, then some appropriate value is returned. I think we discussed this in class on Tuesday, but the Python equivalent is dictionaries. And here I'm setting up a dictionary where these are fake UOID numbers for myself and the TAs for the course. And so this is storing, in this case, here's the ordered pair of a key and a value. And so I'm storing four tuples, four combinations of keys and values, and they're not organized in the same way that I have here, that I have an ordered pair with parentheses. Now they're organized with strings and colons and commas, but whatever, it's a format. And so then this is the store operation here, and they're being stored all at one time. That's not how it's going to work in 3D. You're going to store them one by one. And then here is a fetch operation where I can give it a key. And so if I give it my fake UOID, then it gives my name back. And if I give a different UID, then it actually throws an error. So the functions for a map data structure are store and fetch. And so here are the functions that the textbook uses are put and get. They also have functions like does it contain a key? Can you put it in uniquely if you have two keys? Is empty and remove. And so these are all useful functions that we don't need to implement for this assignment. We're kind of doing contains key because if it doesn't contain a key, we're going to return null. But we could have, for example, thrown an error. So then the question is, well, how do you implement a map? And so there's two ideas that we're going to implement. And in fact, I've implemented one for you. I've implemented the hash table one for you. But one idea is to implement it with linked lists, and the other idea is to implement it with hash tables. So to implement it with linked lists, the idea is you'd have some tuple, and you'd make a linked list of that tuple. And so the store operation would just be inserting a new tuple into the list, and then a fetch would be to iterate over the linked list, and whenever you find the desired key, then you'd return the value to go with it. With a hash table, the idea is to convert the key to indices using a hash function. And of course, insertion is difficult when you have collisions. And so we talked about open addressing and chaining. And so my implementation does open addressing with linear probing, and you're going to change it. It'll still be open addressing, but it will no longer be linear programming. So a store is you do a hash and then you insert the tuple into the hash table, and a fetch is again you hash the desired key and you compare the key with the appropriate index, and you keep repeating. So I'll show you this in my code in a second. In fact, let me do that now. So the first thing is this is the data file that's coming with this project. And so this is a file called companylist.csv. You can see it right there. And CSV is actually a pretty common file format. It stands for comma separated values. And so this is just something I've gotten off the internet, and it is financial information. And so for each of these companies, here is their symbol for the stock market, Here's the name of the company as the second column, the last sale price for the stock, the market capitalization. I don't know what ADR TSO stands for, the year of the initial public offering, and some other stuff that I didn't want to keep track of. You'll note, because I wrote a parser for this file, so I read it in and store it in a data structure for you with my starter code. It uses commas to separate each of the columns, but some of the fields themselves have commas. And so that's a problem when you're parsing. Like right here, you can see it says the name of this company is 3 PEA International, comma, Incorporated. And so every entry is designated with quotes. And actually, if you look at how I parse it, I actually focus on the quotes and not the commas. So here's my starter code. And so I have a struct, which is a company struct, and it has the fields that we track for this project. There's a symbol, name, last sale, market cap, and then IPO year, and the rest I threw out. And there's actually a print function as well, and so you can print what company, or you can print all the details for a company. Here's my read routine, and so it takes in a file name and then a pointer to an array of companies, and it actually initializes this pointer, and a pointer to an integer, and it assigns a value to this integer. So the calling function, when you call read file, we have a pointer to an array of companies, and we have an integer, and then the addresses of these two variables are sent in, and then because we're sending in the addresses, when we call read file, at the very end it sets the values of these two. And so at the end of this, when you call read file, then num companies will be set to the number of companies, and then this company's pointer will point at an array of companies. There's going to be 3,435 companies. The first line just gives you the format. And so num companies should be set to 3,435, and then you should have an array of 3,435 companies. Good. So the reading, you're welcome to look through it all. I do things that we've done in this class. I don't know, how big the file is, and so I do an fseek to the end and an ftell to figure out the number of bytes. And then I actually allocate one giant array for each for all the bytes and read everything in at once. And then as I'm storing strings, I actually just store. This is one array of 3.5 million bytes. And I just store offsets to the 3.5 million bytes. And for each of these quotes, I just set them to null characters. And so that way, for example, there's going to be a giant array, and when I'm storing the company name 111 Inc., I'll store a pointer right there to that location, and then right here, this will be overwritten to be a null character. And so then if I store a pointer to this location, then it will perfectly terminate at the null character. And that way I can just allocate one giant array and then use all of these substrings within the array. So if you're interested in the details of that, you can look at this read file routine. Here is my hash routine. And so this is the exact same hash function we discussed on Tuesday that came from the Sventech textbook. And then here is my implementation of a map based on a hash table. So it has an initialize function, and it has a store function and a fetch function. And so then if I use this, here is my main function. I'm reading the file. I instantiate my map. I put in a print statement because print statements are good, just to make sure that it's reading something good. I do my initialization, and then for every company, I store that company in the hash table. And the function takes a pointer, and this is actually a fine way to get each company as a pointer. If I wanted to, and maybe this would be a cleaner syntax to some of you, I could have done this. and that would be the same thing. So that maybe makes more sense to some of you, but companies plus I does the same thing. And so then after I store all 3,400 companies, I fetch back 4 real companies, and I use my function fetch and print, and then I fetched a whole bunch of fake companies just to make sure that it would successfully return null, and it did. Um, so that then if we look at my code here, and by the way, if you downloaded my code on Thursday morning, I've fixed a bug, and I've added 2 new lines of code right here, and I'll describe that in a second. And so what my code does is it does a hash, and then since it's doing linear probing, it will try to store it at the first location, the location of the hash value. And if that works, if it's null, then it puts it in there and it returns. And if not, it goes to the next value and the next value and so on. And of course, there's this problem of wraparounds, and so this modulo arithmetic is supposed to deal with wraparounds. The problem with my code, and the reason I needed to fix, is because, and I find this to be really frustrating, and I've run into this probably 10 times throughout my career, that if you take a modulo of a negative value, it will still give you a negative value. So, -5 modulo 10 to me should be 5, but it's actually -5. And so this logic here, where we say if it's less than 0, increment it by num elements, we'll deal with that issue. So what are you supposed to do? One of the things you're supposed to do is to do double hashing. So here I'm doing linear probing. I'm saying I'm adding I each time. So this would add 0 the first time, 1 the second time, 2 the third time, and so on. And I want you to do double hashing. And so you'd still use my hash function as the primary hashing, but you should come up with a second hash function. I'd encourage you to do a little research on the internet and find something interesting as your second hash function, and then you'd be putting it right here, I times the value of your hash function for both the store and the fetch. The other thing you're going to do is you're going to implement linked lists, and you're going to implement a map based on linked lists. And so, I posted code on linked lists before, and it's fine with me if you go and use my previous code as a starting point, but you're going to need to adapt it to work with companies, my company struct, and you'll need to put an interface around it for storing and fetching. And then the next thing you're going to do is you're going to run a performance study. And so I lectured previously, I think it was lecture 12, on how to extract timings, and you'll add that to your code, and you're going to, where in this code, we store all the companies in a hash table. You'll have another for loop where you store everything in your linked list, and then you're going to fetch everything out of the hash tables, and then fetch everything out of the linked list, and you're going to time each of those 4 things, and see how long they take, and see what sort of performance difference it makes to use hash tables versus linked lists. These are all very quick operations, so it's not going to be astounding when you only have 3,000 elements, but for myself, I was certainly able to see a performance difference between the two operations. So here's the 3D prompt. Again, it's due on November 30th because I want you to have a path to get all the homework done during dead week and not have to have a backlog of homework entering finals week. That said, if you want to take finals week up through Wednesday of finals week, you're welcome to. As of 6 a.m. Thursday morning, I'm no longer accepting any homework for the class. And so if you submit this or any other homework as of 6:01 on Thursday morning, it will not be graded and be returned as 0 points. But if you want to not turn it in on Friday, November 30th, and instead have your completion of the homework spill into the first half of finals week, it's fine by me. This is a significant project. It's worth 8% of your grade. It's actually not too much coding, although I think that, and so if you implement it quickly, don't get spooked that you didn't do everything you were supposed to do. But I actually think many people are going to have to really learn GDB and deal with seg faults and there's some tricky syntax issues and so on. And so this will be a culmination of what you've learned so far in the course. So the rest of the prompt, says the things that I think I've already said. You're gonna the code I gave you implements a map based on hash tables. It reads this CSV file right here. It defines the company struct here. So here's the company struct. And then I implemented a map based on hash tables that take the CSV data and put it into a map. Your job is to implement double hashing. So you're going to be modifying my code so to no longer do linear probing, but instead to incorporate a second hash function. And then you're going to implement an entirely new map based on linked lists. And it says the key for the map should be based on the company's symbol name. So if you look at how I am hashing or doing a map based on hash tables, you can see when I calculate my hash, I'm using the symbol part of the company. And so, we've got a symbol, we've got a name, and so that means I'm doing my hashing. The key is assumed to be, for this company, PIHPP, and not the 1347 Property Insurance Holdings Incorporated. And so when you're doing your map based on linked lists, I would expect you again to use that symbol in the same way I'm using it here as the key for your map. You're going to do a performance study. So you're going to measure the time to store and fetch with both map. I know it says measure the time to store and fetch with both map times, both map types. And the workload for fetching should be to fetch every company, meaning there's 3,400 companies, and you should be timing the fetch for all 3,400 companies. Not meaning do 3,400 timings, each timing capturing one company. I mean, start your timer, do 3,400 fetches, end your timer, and then report on that time. And then write a report. And I'm going to grade these personally. I don't want a long report. It should just be a paragraph. But it should tell me, what did you choose for your second hash function and why? And then your findings from the performance study. At the end, you upload 2 files, both your code and your report should be an ASCII text file. In fact, let me modify this right now. In real time, you're going to upload one file, and this one file should contain your report, your code, and then in a commented section at the bottom of the file, it should contain your report. And so that way you just have to upload one file. But in the bottom of your file, you'd put, some, here is my report, and then you'd write your report down here in commented form, so it can still be compiled. As you're, and so then I'd like to be able to run your code, or at least be able to run your code if I want to. And so everything that you've done for your performance study should be in there. I should certainly be looking, I should be seeing get time of day calls when I look at your code, and there should be print statements for each portion you timed. And then I understand, you may be running on a virtual machine. Maybe I am, maybe I'm not. And so I understand the timings you get would not be the timings I get. There'll be variations, and that's okay, but I would expect to still see the same trends. Okay, I hope this is helpful for understanding Project 3D. Of course, there'll be class this week, and so I'll be happy to answer questions on Tuesday in class, and I really hope folks watch this video before then so they can bring good questions to lecture. Hope everyone had a good Thanksgiving, and I'll see you in class on Tuesday.